let's look at probability with 2 dice. So, might seem simple before we look at it, but it's kind of a complex idea. We have our dice here. Okay. All right, there's dice 1, we'll call it, and dice 2. Well, my excellent artistic skills here. I'll try to change the face of the dice. Okay, so we have our 2 dice here. We're going to figure out the probability, and they asked us a question, probability of non-perfect square?
Yeah.
The probability of getting a non-perfect square, which, first of all, we've got to figure out what the heck a perfect square is. Perfect square is a value that when you square root it, like a number 9, is equal to a whole number. Okay, so perfect square values are 1, because square root of 1 is 1. Okay, square root that gives you 2 would be 4. Square root that gives you 3 would be 9. Square root that gives you 4 would be 16. And already, what's the total of 2 die? What's the max 2 die can give you? 12. So 12 falls in there, so this isn't an option. So these are your options. Are we rolling a 1, a 4, or a 9? Okay, those are our perfect square options. Okay, so these are perfect squares, 1, 4, or 9. So keep that in mind. Now, to talk about a dice, how many options are there? Okay, if you were to do a tree, you got 1, 2, 3, 4, 5, 6, and then from each of those, 1, 2, 3, 4, 5, 6. Okay, so etc. all the way down. That would be from rolling dice 1 and then dice 2. It is already tough if I were to make a tree to count all that idea. So we talk about the possible outcomes of a dice. Well, we know there's 6 possible outcomes, so 6 to the power of 1 would be 1 roll. Okay, and 6 to the power of 1 is a total of 6. Okay, for 2 rolls, spell that right? Yeah, okay. 6 to the power of 2. 6 to the power of 2 is 36 rolls. Okay, and then if we go on with that 6 to the power of 3, that's a pretty big number. Let's actually figure out what it is. 6 to 3, 216. So it takes off really quickly because the base is such a large number. Okay, so luckily for ours, it's just 2 rolls. So we're looking at a total of 36 outcomes. Okay, but then each of the outcomes is hard to build. Like on a coin, we were kind of talking about the ideas of, oh, you know, we got a head and then a head and a head and then a tail with 2. But with a die, you could go, you know, 1, you have 1, 1, then 1, 2, and then 1, 3. And because it's 36, this is kind of hard to set this up in. So what we're going to do is I'm actually going to build a type of box here. And on the left, I have 1, 2, 3, 4, 5, 6. Okay, I'm going to have 6 rows and 6 columns. 1, 2, 3, 4, 5, 6. And the reason I'm going to set this up is we're going to go through all of the options this way. And the reason this will work is because we'll say dice 1 is in blue. Okay, you have 1, 2, 3, 4, 5, 6. Those are the options. And dice number 2 is in green. You have 1, 2, 3, 4, 5, 6. And what's neat about this chart is I can just quickly build it by adding these values and putting what their outcome would be.
Yeah.
Okay, so when we do that, let's do it in red since I was doing it. 1 and 1 is 2. Right? 2 and 2 is 4. 3 and 3 is 6. 8, 10, and 12 we said was our max number. And then we can kind of just fill the chart in from here. This becomes 2, 4, 5, 6, 7. The reason I start with those numbers is because then I can quickly build this same way. 2, 3, 4, 5, 6, 7. Excuse my S5s. 5, 6, 7, 8. 5, 6, 7, 8. 7, 8, 9. 7, 8, 9. 9, 10. 9, 10, 11. Say, and there we go. We got a nice chart. Okay, so we got all our sums. This is simple to make. Now, perfect squares will highlight. Perfect squares are 1s, 4s, and 9s. Okay. Guess what? No 1s. That works out great. So that's not an option. 4s. Well, if you look in this chart, it's really nice because it goes in diagonals, right? We have 2, 3, 4, 5, 6, 7. What is the most likely outcome when you roll 2 dice? 7. And when you do casino games, you notice that's a really important number. So 4s and 9. Okay. So how many 4s do we have? Well, we had 3 number 4s. Okay. And how many 9s? Well, we had 4 number 9s. And how many total outcomes did we say there were?
36.
36. So it's out of 36. How many 4s and 9s are there all together?
13.
Well, we're just going to count them. So we have 2, 3, 4, 5, 6, 7. And you could have thought of it by just 3 and 4. That's okay. So we have 7. So our probability of rolling a perfect square, and actually I don't think that asked us that, a non-perfect square. Probability of a perfect square, so we'll call that of the event not happening, is 7 in 36. The other way of non-perfect square, then we would have counted all of these numbers, right?
Yeah.
So because we found the opposite idea, we can then set up our formula. Formula that the probability of the event, that's a non-n perfect square, plus the probability of the event not happening, that's a perfect square, is always going to be equal to 1 or 100, right? Well, we discovered the probability of the event not happening. So actually rolling a perfect square is 7 in 36, and then the probability of the event equal to 1, and we isolate. Probability of the event, we bring that value to the other side and it becomes 1 subtract 7 over 36. This 1 can be written as 36 over 36 because we need a common denominator. And we just subtract the two top values, and that will give us 629 out of 36. So the probability of rolling a non-perfect square is 29 out of 36. So what seemed like a really simple question actually took quite a bit of math to figure out.